Okay, so we are live. Welcome everybody to DevOps Toronto December. I am Steve Pereira, your host for the past 11 or 12 years. And this edition, we're going to be looking at something I think is pretty timely. And so I'm really excited about this session. And Varun reached out to us, offered to share what he's been working on, which is my favorite type of presentation: practical, real life case studies, examples from the trenches. So very thankful for that. And I will hand off to him in a moment, but I'm just going to do some quick housekeeping first. So I want to mention that we are sponsored by Cloudbase, wonderful company, does excellent work across the entire software delivery lifecycle. If you haven't heard of them, you should definitely check them out, but chances are you have, because they are massive and they've been at this for a very long time. Our other wonderful sponsor who's been with us forever is JFrog. They also live across the software delivery lifecycle, but primarily focus on things like artifacts, deliverables, things that you build inside of your pipelines. And so with that thanks out of the way, I will take no further time. I will hand off to Varun, who's joining us from Oshawa, true local, who's got a true story to share about his experience moving to or standing up a private cloud infrastructure. So with no further ado, I will stop sharing and hand off to Varun. Thanks, Varun, for joining us. Welcome.
Thanks for the wonderful introduction, Steve. Good evening, everyone. And today I'm going to present about building private scalable infrastructure without the cloud and doing it on a budget. So without further ado, I'll just share my screen here and click present. Okay, who am I? I am a DevOps engineer working in the networks and systems engineering space, passionate about computer networks, infrastructure, open source, and I work for a company called Transnomis, and we are a government contractor, or we are a subcontractor, and we work with local and other governments for road information systems, transportation systems, and we also do things like permits for them. This talk talks about how we built our private cloud at Transnomis and how our infrastructure runs. Okay, so why build your own infrastructure? Why not just go to the cloud? First reason is cost. Like people may overlook the cost factor and just may think that it's just what you have to pay to in order to get your infrastructure. But if you dig deep into how the costs are structured, a lot of cloud hosting companies have like 30 or 40% free cash flow margins, and that's a lot of money that you are leaving on the table. Typically, what we have found is that if you are unless you are really small or very big as in like you may have very high scalability needs, or if you are too small, you just want to get started, you do not have an infrastructure team to run your own infrastructure. In that case, in those two cases, cloud does make sense. But if you're just a general company, like most companies are, who have predictable infrastructure loads, then you may consider running your own infrastructure. The other is flexibility. Because we have our own infrastructure, we can build it exactly how we need. We can fine tune absolutely everything, and there may be compliance needs, or there may be a customer who wants something different. Like some of our customers want them to be in a separate network, or want them to have a separate layer of isolation. We can build that out for them. Also, one thing to keep in mind is that because you're running your own infrastructure does not mean that you have to build your own hardware. There are IaaS companies There's OVH, which we use. There's also Equinix Metal and other ones where you can provision resources with something like Terraform, or they also have APIs. So you can get like the hardware pretty quickly now. So you don't necessarily need to like wait 2 or 3 months just because you're running your infrastructure to get the hardware. You can get it in minutes if you want to. Uh, the other reason is open source. Because of open source software, you can get the software off the shelf. So you for every layer of infrastructure that you run, there is open source software available. You just need to put it together. In some cases like OpenStack, you have it all together. So the software part is kind of solved, and that really enables us to run our own infra. And just going to talk about things which we'll be talking about here, VXLAN and OSPF for building out scalable, isolated, redundant network. We'll be touching upon Proxmox and Linux KVM, which is the hypervisor for running workloads or virtual machines. We use Ceph for distributed file system, and Ceph allows you to run even petabytes worth of file system, and it's highly distributed. It's highly available. If you lose a disk, or even if you lose a machine, or even if you lose sometimes a rack, you'll be totally fine. And it scales wonderfully. Like you can just keep adding disks, and you can scale it to petabytes of storage. We use cloud-init and cloud-base-init for automating the provisioning of the virtual machine. And that ties in with Terraform and Ansible. We use Terraform for a lot of things, including provisioning virtual machines, giving it resources, whatever we need. And Terraform then interacts with cloud-init or cloud-base-init. We'll be talking more about that. And Ansible is for just post-provisioning the virtual machine. You can even use the virtual machine as something like a Kubernetes node. We'll be talking more about that later. We use LibreNMS for monitoring. I know people use Prometheus and Grafana and things like that, but we use LibreNMS for monitoring our routers and our hosts, and we found that it even works absolutely fine for monitoring virtual machines and applications. Yeah, also we'll be talking about hardware, what to buy, how to source it. Sometimes you may not need to source it if you're using like IaaS operator, like we had talked about earlier on the earlier slide. Yeah, also other things like identity management, VPNs, if we get time. So yeah, building the network. This is like a proof of concept network, which is there here, but we now have, I believe, 6 or 7 machines. This was just for proof of concept, where I clicked a pic, was a while back. But yeah, we want the network to be scalable. We want to support, let's say, we should be able to support, let's say, thousands of physical machines. We want it to be fast. We want currently we are running with 50 gigs per server, per bare metal server, which is fed by 25 gigs into 2 ports, and it needs to be redundant. So if you lose a single machine, or even if you lose a router, or if you lose anything else, or even a bunch of machines, or if you just lose a rack, it should be able to work, still able to function without any outage. And it should be secure. We use something called as VXLANs, which are kind of like VPNs, or they're kind of like VPCs, and that allows us to have isolation between different networks. We may be running like separate networks for separate customers, or we may be having separate networks because of security reasons. Like we like to keep whatever the public services separate from the private ones, and things of that sort. And VXLANs enables that. We'll be talking more about all of this in the next coming slides. So yeah, for the networking part, we used OSPF for basically maintaining the link state. And what OSPF allows you to do, it allows you to put all of your machines in a mesh. So this is a very basic, simple example here. And in this case, we have, we just put this at the side, and we have 3 main core routers, and they are all connected with 100 gig links. And then you connect each of the hypervisor. Hypervisor would be the machine running the virtual machines. And you connect a hypervisor to multiple routers. And this allows you to put all of them in a mesh. So even if you lose a machine here, if you lose this machine, or if you lose this router, you are absolutely fine. Or even if you lose multiple links, you are still absolutely fine. And this is very scalable. Like you can keep adding more. Hypervisors here, or you can connect another hypervisor to 2 other hypervisors. So you basically put them in a mesh. Or a lot of people just like to have a very extended ring. So these 3 routers are just 3 here, but people usually like to have one of these routers on every rack. So you kind of put them in a very big ring, and then you connect like each of the machines in the same rack to those 2 routers, or one of the routers in this rack and the one in the adjacent rack. Yeah, so we use OSPF to build a link state, or to put them in a mesh, basically. Yeah, and then we use VXLANs on top of it. VXLANs are kind of like, think of them like VPN tunnels. So if you want to talk, if you want this machine to talk to this machine, and this, all these 3 machines to talk to each other, you just put them in a VXLAN. And VXLANs are, you can pretty much think of them like VPNs, but they are extremely high performance. So we've tried pushing 200 gigs on top of VXLANs, and it has worked without issues for us. We have this VXLAN is for we are using it for storage layer for Ceph. This is for the clustering system. Like I said, we use Proxmox for the hypervisor, and Proxmox also has clustering. So if you lose one of the machines, other machines take over. So we use this, let's say this VXLAN for storage. We use this VXLAN for clustering, and we can have like other networks on VXLANs or on VPNs. And they use like this may be for a customer, or this may be for public networks. We use VXLANs then for each of the devices to talk to each other. And you can also, like if you want to send traffic to the outside internet, you can always send them to one of these routers, and these routers can route them out to the internet. Or you can do whatever you want. Like we use something called as VRRP, which is kind of like keep alive D. If you've heard of keep alive D, it's basically for failover, or you can also, people also call them failover IPs. Basically similar technology to basically send the traffic to whichever router is available. Yeah, I won't bore you with the networking part. We'll just talk about the budget, and we'll move on to the next. Yeah, so this topic is also about doing this on a budget. There are other vendors like Cisco or Arista or Juniper, which will charge you a bomb for this. Like just for the routing capacity that you need here, will charge you like hundreds of thousands of dollars, or maybe billions of dollars. But there is this routing company called Migrating from Latvia, and we use their devices, and they work really well. So we buy these routers from them. They cost about 3,400 Canadian plus tax, and they have 200 gigs. Like these 2 ports that you can see are all are 100 gigs. So they have 2 into 100 gigs, plus they have 12 into 25 gigs, and this is all line rate. So basically, they can forward without any bottlenecks. So it's amazing performance for the price. And we use Intel network cards, which are like 400 to 600 bucks a pop. And we just use DAC cables for connecting them together. You can use fiber, but yeah, these are all DAC cables here. yeah, this is the network part. And of course, you cannot. It's difficult to build all of this network and try to manage them when you're like. We just have like 7 hosts now, but we'll be having way more. So it's very difficult to manage all of that if you're doing it manually. So we just use Ansible for it. The Ansible support isn't the best. I think there is a Terraform module as well, but we found it adequate, and we built Ansible roles internally just to manage these routers. Yeah, this is the networking part. Of course, you can go very simple for this part. You don't need to build something this complex. But if you have a requirement where you need thousands of hosts, or you may have a requirement for like 10 or 20 racks, that is where you'll find that your standard network just won't scale, and you'll have multiple issues, like let's say one of your router goes offline, or let's say multiple machines go offline, or entire rack goes offline. Then you are in trouble. You don't have the redundancy. But if you have like need for like hundreds or thousands of machines, then VXLANs plus OSPF does really work well. So it's all depending on what your needs are. You can just go simple for your network part if you're running with if you have a small requirement. As for the rest, for the hypervisor, we use Ceph on the hypervisor, and the simple reason is that let's say so hypervisor is kind of like the machine where you run your virtual machines. So let's say you are running VMware or VirtualBox, and you have multiple virtual machines there. If that host goes offline, then you want the virtual machines to be available in a different host. You want them to move to a different host, so that you don't have an outage if, say, one or two of your machines just go offline. And we have found Proxmox plus Ceph to be a really good pair together. And Ceph takes care of the storage layer, and Proxmox takes care of basically KVM and rest of the hypervisor part. So what happens, let's say if a host goes down, is that Ceph makes sure the storage, whatever storage for the hypervisor is already shared with all the hosts. So all that needs to happen is that Proxmox needs to tell the other machines in the cluster that this host is unavailable, and then automatically that virtual machine will be available at the other place. And we managed to like, even if we lose a machine, that virtual machine comes up online in like 1 or 2 minutes. So we have tried this out. We have like put a couple of machines just offline. We just pulled the network port, or just pulled the power port, and the virtual machine comes back up online in another host in 2 or 3 minutes max. Yeah, it's completely free. All of it is open source. Ceph is open source, can support petabytes of data. Proxmox is open source. And they also have other products like Proxmox backup server, which is also open source and free. And it's working really well for us. So automating virtual machines on top of Proxmox, basically, like if you want to create a virtual machine, it would be okay if you want to create a virtual machine. If you have like, if you are doing it manually, it would be okay if you just have like 5 or 10 machines. But we have a requirement for hundreds of machines. Then it quickly starts falling apart. Ideally, people use things like Packet, or I think it's called Packer by HashiCorp, or they may have scripts to automate that. But what we are doing is we are using cloud-init, which is a industry standard way of automating or templating VM creation, and we bind it together with a Terraform provider, which works with Proxmox. I think it's by a company called Telmate. It's free and open source, and yeah, both of them work really well to provision a VM. So all we need to do is we say we need a VM with say, let's say 4 cores, and we need like we need 8 gigs of memory, and maybe we need 200 gigs of 200 gigs of Ceph storage, and we just push it to our Git, and it will automatically create that VM. And this is the cloud-init config which we generally would use. And we can also tell it things to do, but generally we keep the provisioning part very simple. It also does things like set up correct host names, DNS, time zones, adds users. We for user and identity management, we use a software called JumpCloud. So it installs the agent with Bash, and yeah, and after that we can use Ansible to SSH in and just run the playbooks. Rather, we don't SSH in, we run the playbooks using GitLab, rather GitLab runners. But yeah, so with Ansible, you just post provision it. Like you have your VM, and then you can run whatever workloads or whatever you want on top. Like you may need to use Kubernetes, so you would use Ansible to provision Kubernetes on top. Or if you want to use a load balancer, we use Caddy load balancer. Then you can use Ansible to provision that, Docker containers, whatever you want, basically on top of the VMs. For Windows, it's a little tricky, but we had good luck with this software called cloud-base-init, and we provision it with cloud-base-init, and then we post provision with Ansible over WinRM, and it works better than we expected it to. Yeah. So we use it to provision our ITS software, and we have other software called Permit. We use that to provision it. And yeah, that is mostly it about the infrastructure. I will be showing more about like rather I will be giving a more practical demo of how things are set up. Yeah, we also use, like I said earlier, we use LibreNMS for monitoring, and surprisingly, it has worked really well. We monitor a lot of things, including services. We monitor ports. We monitor CPU, memory, storage. We also monitor applications, like we get stats using SNMP and SNMPT. Also, we push all syslogs to LibreNMS, and it works really well. We use zero-tier for VPN, and the reason is that because we have multiple sites, it makes it very simple to bridge all of them together, and also allows us to have network rules on the VPN layer. So we can say X host can connect to Y host, or we can say we can say let's say my machine can only connect to let's say the reverse proxy, some reverse proxy, or my machine can only connect to a particular service. So it makes that part really simple, and we are using we use zero-tier VPN. It's actually like, unless you have like a special requirement, it's free for the most part. Up to 25 users, I think it's free. After that, it's like $5 for more 25 users. It's a bit expensive if you want to use SSO, but it's not too bad. Yeah, we'll just demo a few things. This is the VPN part that I was talking about, and we are using Terraform to provision this. And we have network rules. Doesn't show. Yeah, we have network rules, and then you can like tag those rules by a certain name, and then basically you can attach them to users. You can say this user can only access the reverse proxy, or this user can only access this user can access everything, or this user can only access certain service. So you can put in security rules like that. And this is our LibreNMS monitoring. Yeah, we'll quickly show if I can. It can do almost everything. It can do service monitoring, or it can get syslogs. It can get application logs. You can monitor memory, CPU. You can monitor availability. Few other things like you can monitor ports. Also, you can monitor things like Postgres. Yeah, also set up alerts and things like that. We also use it to monitor Ceph. Not sure what's wrong there. Yeah, also it works really well with Proxmox, and you can get like data from Proxmox. And oops. Yeah, and these are all our pipelines. And this is for the network part. Then we have pipelines for OVH, whatever you provision in OVH. Proxmox, provisioning the VPN, provisioning VMs. Sorry, my laptop is a bit slow, so I'll just close a few things. Yeah, these are pipelines for individual VMs. Yeah, I guess this is mostly it. I will hand it off to Steve for questions, and I'll try to fix my laptop and try to see why it's getting slow.
No problem. Yeah, so let us know if there's anything you want to see or hear from Varun about his presentation. Thanks, Varun. That was an awesome tour. We had a question. I don't know if you actually got to answer it, but how many Proxmox hosts do you need to cluster?
The minimum is 3. Can you still hear me, by the way?
Yeah, yeah,
because my
we can
laptop
still
is
hear you.
like totally freezing up. Yeah. So the minimum is 3. Yeah, 3 should be absolutely fine. We should be able to cluster with just 3. But to keep in mind that Ceph likes as many nodes as possible and as many SSDs or storage devices as possible. So minimum should be 3, and 3 should be fine. We started with sense. If you want more storage, then Ceph really works well when you have like 5 or 7 or minimum of 5 or 7 machines. 3 should be fine though. But you can use other storage layers on top of Proxmox. So do look into that and see what fits your requirement.
This was really cool to see because I think the last time I played with Proxmox was probably around, I don't know, 10 or 11 years ago. So very cool to see that it's still going. Another question, is there a minimum network link speed?
Should not be. I think Ceph requires minimum of 10 gigs. 10 gigs is really recommended. But if you want to run something else, like a lot of people run NFS, like they just have an NFS storage and they connect it with all of the Proxmox hosts. Like we do that with a site on OVH. So we use a product of theirs called NAS-HA, and it's like a high availability NFS export, and we connect it to multiple Proxmox machines, and we can get by with running like 1 or 2 gigs networking speed. So Ceph, like if you're running Ceph, it really requires 10 gigs minimum, and that's why we decided to go 25 into 2 for our infrastructure for the host, just because of Ceph. Like Ceph just allows high network speed. Also, it's really convenient. Like if you have when you have like a lot of storage and a lot of data, like backups can be a real problem. Like I think just one snapshot of our backup like can take terabytes. So when you're handling like terabytes worth of backups every day, you need fast storage. Trust me.
And that's only between nodes. It's not like you need that out to the internet, right? Varun, we had one more question. Oh, can't unmute yourself. I can probably do that. How's that?
Yeah, can you enable by video as well?
Yes. Yeah, I just turned it off because of your connection speed.
Yeah, it
But
was
it looks like it's better.
Yeah, my laptop was just hanging up for some reason. I can read the question, so I'll go through them. Is there a minimum network link speed? Yes, 1 gig should be okay, but Ceph really allows 10 gigs. But if you have a big, if you have a big cluster, then 50 gigs is not expensive. Like I've shown the cost. It's not at all expensive now. 10 gigs is pretty cheap now, and 50 gigs is not expensive. So why not if you're running your own infrastructure? Yes, the Unify switches are excellent. Unify is excellent. We use Migrating just because I had more familiarity with it, and yeah, we know a good vendor for Migrating, so we work with them. But Unify is excellent. I work with Unify and it works absolutely fine, absolutely good. Are you bootstrapping Kubernetes on top of Proxmox VMs? We are not, but we do plan to go in that direction. And I've tried Kubernetes out on Proxmox, and it works really well because you have the redundancy on the Proxmox layer, you have redundancy on the storage layer, and you can have redundancy on top of that. So I guess very few things can go wrong there, and you still have the flexibility of being able to modify things on the VM. Roughly what CPUs? So we are using we are just using consumer grade Ryzen CPUs, and they work with ECC memory. So you can have ECC memory. You can we also plan to add in IPMI, but yeah, consumer CPUs work really fine. Unless you have like a specific need, I would say per dollar cost, consumer CPUs work fine, and you do have redundancy on the Proxbox layer. So I guess it makes sense in this case. But we also run a similar cluster on OVH, and that has been fine as well. The mix of Intel and AMD CPUs. Yes, I have tried vSphere and ESXi in a home lab. You should definitely try out Proxmox. It's really good. You like I actually bought those small mini PCs. Like you get those mini pocket-sized PCs for home lab use, and there is this mini PC called Lenovo M920 Tiny, and you can basically put a full network card in there. It's like 1 liter PC. It's super small, like size of my phone, and you can put a mini PCI card in there. So you can I put 2 into I think it is 2 into 40 gigs InfiniBand to IP cards, and I can have 80 Gbps on my 1 liter PCs. You can then use Ceph on them. So yeah, Proxmox is really good on for home lab use as well. Have we tried integrating any APM tools? We have not. We have not. We'll need like we don't have. We actually don't have much performance monitoring, and we do plan to solve it. So we may look at that. So log aggregation so with for log aggregation, we are just pulling the system log. But what you can do is that like systemd journal D, with systemd journal D, you can log application logs to the syslog, and then the syslog will be exported with something like rsyslog to libnms. Yeah, any more questions?
What's next, Varun? What are you working on? What are you going to add to this? Are you going to scale it up? Are you looking to kind of swap out components?
The goal is to scale this up. Like, we still have a lot of things on the old infrastructure, and it's just a process of moving things over, which takes time and planning. So yeah, it's a lot of just moving things over onto this infrastructure. And I guess our future goal would be to try to move to things like Kubernetes or containerize our application. But it can be difficult because we need to remember we work very closely with the government, and they have requirements which are very different to a SaaS company or a company working very closely with containers. So you need to keep that in mind. So yeah, that I guess that would be the goal in the future. Try to move to containers and things like that. And good news is that we can run containers on top of Proxmox or whatever we've built.
Do you find that most of the apps that you're migrating are similar? Like, is there a lot of variety in the requirements or dependencies for each app? Is it like each app is very unique, or do you find that it's just a matter of churning through them because they're very similar?
So what I've been trying to do is I've been trying to like simplify a lot of deployments, and because like there was a lot of variability in every deployment just because the requirements are very different. So I've been trying to simplify that part, and yeah. So like I said, it's a process, and the other thing is we do want to try to move to, like, our application is .NET, a pretty old version of .NET. So things like that, we are looking at like getting to the latest version. Then we can like think about containers much more easily. Right now, it's the web root part or the web server part is on Windows, and the database is on Linux. Yeah, things like that. Few things to iron out. But yeah, like if a single application can be like standardized in terms of deployment, but still there are some variability and moving parts. We are working towards it.
We got a couple of questions pop in as we were speaking.
Yeah, I'll try to go through them. What hardware are we running it on? We are running it on consumer grade Ryzen CPUs because they support ECC memory, and they have support for IPMI. If you want, like, you can run IPMI on consumer hardware. So we don't have a requirement for going for getting enterprise hardware. But we also host on OVH, and we have Intel and AMD hardware there. So it works fine across any hardware you use. Are you running mostly your workloads in VMs? How do you manage containers currently with Proxmox? Yeah, OpenStack is really good. You can also look at OpenNebula. We were using OpenNebula at a company I worked for earlier, which was a cloud host. So yeah, you can look at OpenStack, but we found that we didn't have like cloud-like workloads. A lot of the workloads were VM-like, so we decided to go with Proxmox, and we were running Proxmox earlier, so there was good familiarity with Proxmox. But yeah, OpenStack is excellent if you have the requirement, like cloud-like workloads. Also look at OpenNebula. It's pretty decent. If not your electricity good, I'll say to completely down as you're just one there. Then to another similar. So yeah, we do have like we do have a availability zone, if you can call that, in OVH. But yeah, currently we don't have super production stuff on this cluster. We will be moving it to a data center soon. So after that, or rather, we do have plans of doing it. So yeah, I guess we won't have power issues after that. But yeah, there's nothing super critical on this. But we do have like lots of UPS backup. So even if we lose power, like we should be good for at least half a day, I guess, maybe more. We do have good UPS power, and we do have generators. How many VMs can you run at the same time? You can run like on this similar setup. You can run 10,000 VMs, 1,000 VMs, 10,000 VMs should be absolutely fine. Currently, we have like around 100, I guess, because we are still in the process of moving over VMs. What's the RAM like? Each machine with consumer CPUs supports up to 128 gigs of ECC memory. We use ECC memory. It would have been nice if it supported more, but 128 is okay. We just put more nodes. Yeah, I guess those are all the questions. Any more questions? We went with NVMEs, but with Ceph, you need to keep in mind that you need enterprise NVMEs or NVMEs which have which have this thing called I think it's called write protection or something, and that's just because Ceph needs to Ceph sends a command to flush the buffer every time, and that can be a really expensive operation on consumer CPUs. So it just kills the write IOPS. So make sure you're going with enterprise NVMe SSDs or just enterprise SSDs with Ceph. No, we do not need a RAID controller. Actually, RAID controller is not desirable at all. If you have a RAID controller, you should put it in JPod mode or just get a HPA. You should not use a RAID controller with Ceph. Yeah, we use Ceph file system, which is a distributed file system and scales to petabytes of storage. Distributed, highly available file system. We use ZFS for backups, but yeah, it's mostly Ceph and CFS for backups. Yes, local NAS ZFS works. It's really good. Even if you want, like, for a small cluster, if you just want like NFS exports, ZFS and TrueNAS or FreeNAS, I guess it was called, works really well. We use ZFS for backups, and Proxmox also has this free and open source product called Proxmox Backup Server, and with Proxmox Backup Server, it uses 30-bit mapping, and it uses ZFS's deduplication feature, and you can have full backups with the advantages of incremental backups. So your backups are super fast, and you don't need it does not store the entire backup. Rather, it only stores the incremental part, but you still have the full backup. So Proxmox Backup Server does intelligent things, and we use that to do backups. Yes, and it uses ZFS. Do you have failover options? Yes, we have failover options for everything. We have, like, if we lose routers, we are fine. If we lose servers, we are fine. If we lose, I guess in some cases, if we lose VMs, we are fine. But yeah, there is storage, there is failover at every layer, including the storage layer. Any more questions? No problem. Thanks for tuning in.
All right. Well, we might as well wrap early. Give everybody some time back. Get your dinner or the rest of your day squared away. And Varun, I'm sure will be available on Slack for a bit to answer questions. Varun, did you want to share any connection information? I know you shared your Twitter and did you share Twitter? Actually, Twitter or LinkedIn? If you're,
I think I shared my LinkedIn. I do not have a
okay.
Twitter,
All
but
right.
you can just Google my full name, Varun Priolkar, Priolkar, Varun Priolkar, and you'll be able to find my website, my LinkedIn, and everything else.
Awesome. All right. Well, thank you so much for taking the time and sharing. I really appreciate it. And we'll see everybody in the new year.
Thanks, Steve. Thanks for having me.